Okay, right, hello and welcome back to another video. So today we're going to be talking about color gradients. So specifically how we can take advantage of some of the tools within Unreal to use color gradients, coloring our materials and our visual effects. Now this is something I've covered before, but we're going to go in a little bit more detail. There's a few new techniques that I've learned about how we can do this. So we'll cover the basics and then we'll kind of move on to the more advanced stuff. In case this is brand new to you, or if you have a bit of an understanding, maybe just skip on to about halfway through to when we get to the particles, which is when we're going to be doing some more new interesting things. So what do I mean by color gradients? Well, I have here a texture. This was made just in Photoshop. Black on one side, white on the other. I tend to put black and white in my color gradients. I always want to be able to have pure black and pure white, but that's kind of up to you and your art style that you're using. But the important bit is these colors in the middle. So here I've called this fire gradient. This has got sort of oranges and yellows, and this is going to be useful for doing coloring, colorization of our work. So there's lots of advantages to using color gradients. Personally, I'm colorblind, and so I get my color gradients approved and made by other people. Which helps. Obviously you can kind of color pick and things like this, but it allows us to sort of have flexibility and reuse. So this is a very old technique. It's been used as far back as sort of Halo 1. It's one of the first examples I saw using this. And it means we can use the same texture with different gradients and get different results. So there's a flexibility of sort of workflow, which is very handy. And there's also a kind of a reuse of assets. So an art director could come in, change this and say, oh, I want a bit more red in my color here in the sort of the darks. They'll add a bit more red, and suddenly every fire in the game that's using the gradient that's referenced to this will be updated, which is very handy in that kind of like workflow scenario. So textures imported. If you do want to use that technique, one thing you do need to do is just to clamp the X and Y edges. But actually using textures as color gradients is a little bit outdated these days, and we'll see that how we can do colors in the engine directly. So I'm just going to create a new material, class gradients, something like this. And if I bring that texture in, and you can see I've got a few copies of it because I've been using it for a while. If I just plug that into the RGB, you can see our kind of color gradient here. And the way we apply this to a texture or to a black and white texture is just by using the UVs. So the gradient is aligned with the dark colors on the left, the bright colors on the right, and then there's sort of the gradient that goes along through the middle. Now this has been imported at this resolution, 1024 by 256. We actually don't need this of the 256, so the gradient itself could be very, very small. And we'll see that when we see the colors. So this is a pretty wasteful texture, really. We've got about 255 pixels worth of data that we don't really need. But it's not a huge texture, it's probably fine. So how do we use it? Well, if I use a linear gradient, and let's say I plug my U values in, nothing's going to happen. Linear gradient, U gradient, has got the same arrangement as our color gradient is sort of set up. But if I use the V values, now you can see we've sort of rotated that, reoriented it, or swizzled it, I guess. And we can use other types of gradient as well. So if I use a diamond gradient, what's going to happen here is our diamond gradient has white values in the center, black values around the outside, and then mid-grays in the middle. And by plugging that into our color gradient, we can kind of remap the black and white values and apply those colors to it. And that works really nicely. And you can see here we're getting those kind of oranges and yellows through here. Now what's nice about this is we could convert this to a parameter and then plug in a different color curve. Not sure if I actually have any in here. If I type in gradient, heat map gradient, there we go. That's a gradient that comes with the engine. Far too many colors to look good, but you can see the process being applied. So the gradient has lots of colors in it, and we plug it through a black and white input value into the UVs, and we'll get this value through. And we can also use textures. So if I were to use a fire flip book, here we are, torch flip. This is just black and white data, and then we can plug a single float channel in, and we'll get that color applied. Let's go back to using the fire gradient, shall we? Like so. Now, as I mentioned, you do need to clamp the edge pixels. If you don't, you will see the engine crash like this. Okay, give me 1 second. Okay, right, we are back. Luckily, there's one I made earlier, so we didn't lose too much with that crash. There we are. So we've got our texture sample here with our gradient plugged in. I'm going to change this. Ooh, let me just change the widget reflector. No, not that one. What do I want? I want debug widget reflector. Make things a bit bigger. See what's going on a bit more. So where were we? Yes, we have our color gradient. I'm just going to go to an unlit material. We have our color gradient here. We have our black and white data plugged in. If I do a texture, what was it? It was called torch fire, like so. Plug that in. Now what I was trying to demonstrate is if I open this up, if we change the edge tiling back to wrap, which is the defaults, what we should see is this. So if this is the error you get when you're dealing with your gradients, all that's happened is the black values have wrapped around to white, and we're getting this kind of this white background when we should be getting a black background. But it's an easy fix as long as the engine doesn't crash on us. We change it to clamped. There we go. Okay, so this is the sort of legacy workflow. It's been used for a very long time. As I say, Halo 1 era. They used the same particle texture for all of the muzzle flashes, and whether it's plasma or shotgun or whatever it is all just to do with the color gradient that's applied to it. So it's a really nice technique for getting a lot of reuse out of single textures, because the color gradients themselves can be very small textures. But we're not in that era anymore. We're now a bit more up to date. And what we can do is in the engine, if I open the content browser, is we can create our own color curves directly in engine now. So in the miscellaneous section here in the create menu, we've got curve, and we can do a curve linear color. I'm going to call this class colors, something like that. Default here, just black to white, but we can click the top, create a new color, sort of stop, a new color keyframe, and we'll do something pure blue, maybe something in here that's pure red. I'm just going to use some really obvious colors to make it clear what we're doing, but obviously we can kind of use nice colors that suit whatever we're making, and I'm going to just rearrange these to be a bit more pleasing, maybe something like that. So we've got blues, reds and greens, blending between the three, and we've got a nice color. So this is a color curve asset. We can't add a color curve directly, but we can create a curve atlas. So there's an extra step that we need to do. So we've got our color curve here, and we're going to create a curve atlas. No, not that. So again, in miscellaneous, you have a curve atlas, and what this does is allows us to take multiple curve data, sort of to the curve color curve data assets we've got here, and basically write them to a texture that then Unreal can plug in and use as its texture. So curve atlas, like so. So this is 256 wide. It's defaulted to being square, but there's no need for it to be square. We can set how many curves we want to be in our curve atlas. So if I set that to 4, and then I can just manually link the 4 curves. So fire 1, fire 2, fire 3, and these are just different variations of colors that might be useful for fire. And then of course the one we just made, the class colors, and you can see here what we end up with is a 256 by 4 texture, with each row being a different set of color curve, which is a really efficient way of working. So to access that in a material, we'll use a curve atlas row parameter, and I'll call this, I don't know, color curves, something like that. And it's the same workflow. So inside this node here, specify which atlas, so the class curve atlas, and then which curve, so such as class curves. And there we are. So input wise, whatever we want, gradient, linear, UV, diamond, or texture. As long as it's black and white data, it will just apply the color to that. And then now we can swap quickly between the different colors, like so, which is all very quick and efficient. And this, because it's a parameter, if I were to save this material, I have a material instance for this. We can actually overwrite this at the instance level as well, so you can change your colors and curves here, which is pretty useful. So that's the sort of material workflow. But when we're getting to Niagara, we can do a little bit more and use those curves as well. So let's start with a new Niagara system. And I'm just going to use the fountain. So we have some particles. Class example, something like this. I'll make them a little bit bigger so they're a bit easier to see, like so. So we have in our initialized particle a color input. Now this is just directly setting the colors, and if I change this to be red, you'll see obviously our particles update to red, but we can also override this input with a color from curve. Now this interface allows us to do exactly what we were doing before. We can set curves directly. So now I've got some red in the middle. Let's do, a bit tricky to select the right pins. Well, it's not really working. Why are we not getting our color curve? Well, because of the index here, we're setting our particle's color via the age. Well, the age of the particle in particle spawn is always 0. So the only thing that's going to be affecting it is this sort of stop here, this keyframe. And we can see that. So now if I change that to then blue, that's now purely blue. If I were to move this out of the way, now I'm getting red. So we're not really using the full range of data in this curve. But we can change our index to be anything we like. So now we're getting a random value between 0 and 1. So the value we're looking up in this curve is, or the value we're using to look up in the curve is between 0 and 1. It's just a random value, and that's getting applied to our particle colors. Pretty cool. Now with this interface, what's really nice is we can do an import, and we've got two options on import. We can copy the curve data. So if I were to use the class colors, all that does is it just populates the in Niagara curve with the data from the content browser, from the asset. So now I'm free to change these spots. I can change the colors, I can do anything I like. So it's a way of saving the data, so saving the color curve to then obviously be updatable data. Or we can actually link the asset directly. So create asset reference, class colors. Now we've actually got a link to that on the content browser. If I open this up, if I change these values, so we'll kind of create a bit more kind of purple in here. What we should see if I do this, when I save and then refresh, might need to do a full rebuild just to get that to refresh, but now we've got a lot more purples in here. So if we had one color curve that was, let's say, controlling a fire, and that fire was kind of using reds and oranges, we could use the same color curve for our materials, the same color curve for our particles, and we're then able to kind of refer back to that as a single place, so that suddenly the art director says, okay, all the fire in our game is now green. We can do that. We can very quickly just change those colors, and it's going to populate and update through all of the assets where it's been linked, which is a really nice workflow. Cool. So that's really good if we want to pick a random color from our curve. We can do a random index here in our initialize. But what happens if we were to animate? Well, if I reset this, leave that there, I'm just going to remove the scale color module entirely and instead use a color module. So the color module will set the color of the particles directly. But because it's here in update, it's going to do it every frame, which is going to allow us to animate. So if I do color from curve, and then again, I'm going to import an asset reference to class colors and the curve index. So here it's defaulted to normalized age. So our normalized age particles are spawning at blue, at dark, at this sort of left color, and then over time they go across to the yellows, to the bright colors. Now that works very well. If that's what we want, if we want to use the whole color range of our asset, we totally can do, but we don't have to. We can control this value directly. So in this case, what I'm going to do is I'm going to take an add, and for both of these, I'm going to change the input. So the first one, I'm going to do a random value, and I'm going to add two values multiplied together. So what am I doing here? Well, if I just zero this out for now. So my random value, you can see we've kind of achieved what we had before. I'm randomizing a value between 0 and 1. This is effectively as our start point in our color curve. So we're randomizing all the way from 0 to 1. So let's say I just want to randomize between 0 and 0.25. So I'm going to pick some of these dark blues as my initial color. And that's working. You can see we're getting darker values, we're getting brighter values, but they're all within that color range of those dark blues. Now before, what we had was adding the whole time. So we were always adding the lifetime, the 0 to 1 value. Well, rather than doing that, if I do normalized age, we can choose to add as much normalized age as we want. So in this case, if I were to take 0.25, well, maybe that's not quite enough, let's do 0.5. Effectively, we're specifying how far through the color curve do we want to add. And so if that range here, this 0 to 0.25 is our start point, our 0.5 is how far along. So some of them are going to spawn there and go to the red in the middle, some of them are going to spawn here and they're going to get all the way to the green. If we were to do 0.75, now potentially we're going to have particles that spawn at this point with their initial value, and then they're going to add up to 1 at their final value. So we're going to use the full color range, but we're doing a random start point and then a kind of like a distance along, which allows us a lot of control over what our particles are doing. Now, because this is normalized age, if particles live longer or shorter, that's going to sort of be updated because it's using the normalized age there. But we can also go further with this as well. So we could do a random value in here as well. So some particles barely update their color, some particles very quickly just clamp out at white, and you can see any values that go over 1, they just kind of clamp, all depending on the type of effect that we're making. Cool. So how can we push this further? Well, in this case, we've animated our color here, we're referencing our class colors. If I were to, let me just save before I do this, just in case it crashes again. If I were to duplicate my fountain, so we've now got twice as many particles, what I could do and say I'll have some particles here that are going to spawn in the dark blues and just have a little bit of blueness to them, particles here that spawn in the reds, so we'll do 0.65, and then there's a bit more animation to these ones. We can see, especially if I make these ones a bit smaller, we're getting completely different color sort of responses from the same color curve, but we've kind of duplicated our data again. So if I were to change this and say, actually, I don't want to use this, I want to use one of those red and the orange fire curves, we'd have to go into here and update it. And in this case, it's not too much work. There's only two emitters, but we can actually expose our color curve here. We could save this at the whole system level. So where we've got the whole system wanting to share our colors, we can do that. Now, this worked in my quick test. I have had issues with this in some versions of Unreal, so we'll give it a go and see what happens. So color curve here. I'm going to call this my colors, and I'm going to do an asset reference to the class colors like so. And now this, because it's been set at the system parameter, should be accessible here. And so I'm just going to take this curve index data that we set, just cut it so I can link this to my system curve and then place that back in again. And then if I do the same thing on this side, so I'm just going to cut that data, link that to the system, just place that one back in again. So so we're using our system color curve up here, and you can see we're getting those kind of yellows and blues. If I then change that to be the fire, that's updating both these systems at once. So we're trying to really minimize how many times we're directly setting where our colors are and how they're used. Gives us a lot of flexibility, a lot of quick iteration time, and also kind of saves us having to do rework and things like that, which is a really nice way of working. As I say, that hasn't always worked for me. Sometimes it will just render as black, Seems to be okay here. I'm in 5.3.2 in this example, so it may be better in the later versions, but I have had issues with it in older versions of the colors in the system not being read properly by the emitter. Okay, well, there's one more thing we can do. What we've been doing in Niagara so far is just taking a color out of a gradient and applying it flat to the whole particle, and so we're getting these kind of flat blobs. Now what happens if we wanted to do what we were doing more in the material, where we had kind of a fire flipbook and we had black and white values and we wanted to apply a color gradient to that? We can do that from Niagara. The way we do that, if I just take my material, oops, here we go. I've got a particle gradient material here. Let's just make it from scratch because it's got some things in it. Class particle gradient. What we're going to do is just make a simple material, so unlit and additive. I'm going to use a texture sample, and the input is going to be a diamond gradient. Again, could be any black and white values, can be a flipbook, can be textures, just needs to be black and white data. And the texture object, I'm going to do a texture object parameter. And call this color gradient. So I'll set my default to be my fire gradient, like so. And we can see we're getting exactly what we saw before with our material. The color gradient is being applied. Let's do that, so it updates. So the color gradient here is being applied, and this is a texture object. And because it's because it's a parameter, we're able to sort of reference it by name and actually update this from Niagara, which is a really nice way of working. So if I go in here, just change that sprite renderer, let's do it to both. A bit small, well, let's maybe just turn this one off, make this one a bit bigger. You can see here we're getting those little diamond shapes. Obviously there's some random rotation to it, but we're getting the color gradient through that. And what we're going to do, we've not used particle color, so this color node here is not doing anything. And instead we want to go to our sprite renderer, go to our bindings, and we can create a attribute binding. And what this will let us do is take data from Niagara and control the attributes in our material. So the attribute we want to edit is the color gradient, and you can see it populates that list. And the variable that we want, well, it doesn't exist. We need to do one more step to make that work. If we go back to where we've set our colors, our color curves up here, we can just expose curve to material. So here in the advanced options, the little down arrow, enable expose curve to material. We can give it a name, or we can just use the default name. We should now be able to do color curve, and you can see the update there straight away. If I change curve fire 1 here, and let's do curve fire 3, and what was it, my color curve class colors, there we are. So there does seem to be a little mismatch. If I do curve fire 1 here, this is what I would expect. If I don't set it, it should be the same. So there is kind of a value being set differently, because this is, no, this is going to be not the same, because this is the texture input one, isn't it? Okay, I see. So it isn't actually the same, it's just similar colors. So this is using a texture as a placeholder, whereas this color up here, fire 1, this is from the linear curve, or from the color curve from the editor. But obviously we can compensate that with our values in our system. There we go. So for example, if we go back into the material, if we were to then multiply by particle color alpha, now we're able to kind of glow that up or bring it down, like so. So, in summary, color gradients old school technique, been around for a very long time, has a load of real advantages in terms of asset creation and reuse, things like that. Old way we do it was by importing color textures. Just need to be colors applied into a texture. Only need a few pixels from top to bottom. Make sure that the edge pixels are clamped so that you get the wrap correct. But apart from that, all we're doing is loading in different fire gradients or different color gradients. But much better way we can work now. We don't need to fill our content browser with loads of texture imports. We can do our colors directly in editor using color curves. So here, miscellaneous color curve. And then the way we process that into a texture is by using a curve atlas, which will then allow us to select them inside a material. Or if we want to use this in Niagara, we can reference the color curves directly and then process them into our particles, either with a random sample or a sample plus a sort of animation component. So we can pick a random start frame and then move forwards through time, or we can actually just pass the data right through back to the material so we can get full access. And the advantage of obviously doing that is if we've got some fire sort of flip books that are wanting a full gradient, and we've got some embers where we just want a flat color, we can have the same setup, all referring back to a single asset, single curve asset, which is then very easy to go in and adjust, add data, take data away, change the colors, whatever we want to do, and it should automatically update. If it doesn't, just do a full rebuild, and there we go. Now we've rebuilt that color and we've got those updates in our system. Okay, right, hopefully that is helpful. As I say, I use this all the time. Color's not my strong suit, and so being able to reference back to colors that I know are sort of approved by the other members of the team, it's a really good way of working for me, for my sanity, so I don't make green fire, which is a thing I've done multiple times in the past. But yeah, there are other advantages apart from just dealing with color blindness. They are it's more sort of flexible, more reuse, more just more powerful as a workflow than baking your colors directly into your systems. It'll save you lots of time in the long run, and it'll make things easier to make to start with. Okay, cool. As always, if you have any questions or comments about anything that we've done today, or anything that you would like to see on the channel, please do let me know. As always, huge thanks to everyone who supports me, everyone on Patreon or YouTube. If you'd like to know more about Unreal and materials and particles and all the things, I've got some courses out on Udemy and Gumroad, so do go check those out as well. And as always, have fun with Unreal, and I will see you all next time.